Hello and welcome to Unit 5 on circular motion and gravitation. This is the first video in the series and it's going to be focused on Lesson 1, Kinematics of Circular Motion. Now before we get on to example question number 1, I want to talk about a little overview of what this lesson is going to entail. So two big topics in this lesson. We're going to be talking about speed and velocity when dealing with circular motion. And we're also going to be talking about centripetal acceleration, which is the acceleration while in a circle, essentially. And in this particular video, we are going to be discussing exclusively the speed and velocity in circular motion aspect, mostly because it leads into the first example problem. All right, so with that said, the first thing I want to do is break down this first formula that they give us. So the first formula is velocity is equal to 2 pi r over t. All right, that may not mean too much to you yet, but we can break this down pretty quick. 2 pi r, I think many of us can recognize that as the formula for finding the circumference of a circle. If we know the radius of our circle, we can use that to figure out the arc of that circle or the circumference. So I'm going to just put here circumference, or just circ for now. All right, t is the period. And so let's put period. And what the period is the time for this. What is this? This is a vial, if we look at the question, in a centrifuge. T is the time that it takes to make one lap around the outside radius of this circle. So we can say this is the time to go around, I guess. And if we compare this to any other velocity formula, this is the distance, and the period here is the time. So nothing really that groundbreaking, right? Velocity is distance over time, or velocity in a circle is the circumference over the amount of time that it takes to go around that circumference. All right. So one last thing I want to mention before we get into this example problem, and that is direction. Direction of an object traveling in circular motion. And it's not entirely intuitive at first, but we have to think if we have a pair of scissors here. So let's say this is a mass and it's on a swinging around this, well, in this case it's a centrifuge, but swinging around this arc here. And we were to take a pair of scissors as it was here, and we cut right there. Well, if we cut right there at this moment in time, let's choose a new color here, like that. Our object is going to fly off tangentially, which means that it is going to fly essentially straight away from the circle in the direction that it was currently traveling. So the velocity at this bottom point is straight to the left. All right, but now let's say, maybe this object it had done like a third of a turn or something, and this object was now up here. Okay, so we have an object, and sure, it had some sort of mass on it. Okay, now the object is here. It's still curving this way, right? It's curving around the edge, and we took a pair of scissors and we cut it right there. Well, this object now is going to fly off at this tangent. It's going to be flying up and to the right, because this is its velocity at that point. So the direction of the velocity, we say, is tangent to the circle. Wherever it is, if you snip it with a pair of scissors, it's going to continue flying essentially 90 degrees from the angle formed to the center of the circle. All right. That, with a little bit of practice, will become a little bit more obvious if you're still a little hung up on it. But I think it's time for us to jump into this example problem. So I have it a little bit drawn out here. It says a centrifuge is spinning at 3,600 RPM, or revolutions per minute. If the speed of the test tube end is 85 meters per second, then we are to determine the diameter of this centrifuge. All right, that shouldn't be too tough of a task. Let's jump into it. We already have our diagram drawn, and something I think we can sketch on here is the velocity of this thing. So at this point, well, this object is kind of flailing itself around here at 85 meters per second. All right. Now, we were pretty sure we're going to use this formula because it has essentially everything we need: velocity, radius, period. And I think all of those things we can solve out of this problem here. So to start off, we are going to do some unit conversions. It gives us 3,600 revolutions per minute. That is saying that this tube, this test tube, is going to fly around the centrifuge 3,600 times in a minute. But we want the time for one revolution, right? Time to go around. Well, from that, we should be able to get period. And it's going to be a little bit of an awkward solve, but I think with a little bit of practice, you shouldn't have any issues with this. So let's go into maybe red and start off. So we're given 3,600 RPMs, which is equal to 3,600 revolutions per minute, or I'm just going to put per 60 seconds. All right. Well, if we work that out, this actually works out to 60 revolutions per 1 second. I think most of us can see that. But what we want, well, we want period. And period is time per revolution. So how do we get from revolutions per second to seconds per revolution? It's very easy. We just flip our scenario. So if it takes 60, if we can do 60 revolutions in 1 second, essentially the same thing we're saying is that in 1 second, we can do 60 revolutions. It's just something we can do, right? It's saying the same thing, just in the other way. And if we say that in 1 second we can do 60 revolutions, we want to know the time for one revolution. So we say, we divide 60 into 1 and say that, well, we can do one revolution in 0.0166, and that's repeating seconds per revolution. And that, folks, is a very useful value because that is our period. Amount of time, 0.0166 seconds to go around one time. All right. That said, I think we can start working with our formula. Okay, we're looking for the radius on this thing. Actually, we're looking for the diameter, but the diameter is just 2 times the radius. So going back into some formula work, I'll write the formula out again here. V is equal to 2 pi r over period. And we can do a rearrangement here, and we can say that radius is equal to velocity times period over 2 pi. Okay, and if we want, we can fill in some values. We can say radius is equal to our velocity of 85 meters per second times our period of 0.0166 seconds per revolution, all divided by 2 pi. I'm just going to leave that in the form 2 pi. Okay, if we plug that into our calculators, we end up getting a value for radius of, let's start a new line in a new color, why not? A radius of 0.226 meters. And if we're looking for the diameter, we can say diameter is equal to 226 meters times 2 works out to 0.45 meters. And that, folks, is the answer.